So in this next section, we're going to be taking a look at multiplying and dividing rational expressions. We'll first take a look at multiplying rational expressions and do a couple of examples of that, and then we're going to take a look at dividing. So the procedure that you would use to multiply rational expressions is very similar to the ones that you would use to multiply rational numbers. So just a couple of examples here. We'll take a look at one where we're just multiplying numbers without variables, and then we'll take a look at numbers with variables. So when you multiply 5 over 8 times 4 over 15, if you recall from the past lessons in previous years, you would multiply your numerators together. So in this case 5 times 4, and then your denominator 8 times 15. And then you can do some reducing, okay? And so in this case, a 5 goes into 5 once, and a 5 goes into 15 3 times, and then 4 goes into 4 once, and 4 goes into 8 2 times, and so then you complete multiplying your numerators by going 1 times 1 is 1, and 2 times 3 is 6. So when we're looking at fractions that involve variables, we can go through the same steps. We want to multiply our numerators together, so we want to go 4x squared times y squared, and then 3xy times 8x in the denominator. And we can do some reducing again. So we can reduce 4 into 4 once and into 24 6 times. And then x squared divides evenly into x squared, so x squared goes into x squared once and into x squared once. Now with the y squared, if you recall, when you are dividing two powers that share the same base, you will subtract your exponents, right? So we have to imagine that there's a 1 on here. And so y to the 2 divided by y to the 1 is y to the 1, so that's here. And that leaves you with 1 in the denominator. Okay, and so now you can multiply your numerator together. So 1 times y is y, and then 6 times 1 times 1 is 6. And just remember that when you are working with rational expressions that involve variables in the denominator, that you need to concern yourself with non-permissible values. Okay, so where did these ones come from? We've gotten 3xy, which we know can't be equal to 0. So we can start by dividing both sides by 3x, and we can see that y can't be 0. And then we can also go 3xy can't be equal to 0, and this time we're going to divide by 3y, and we get that x can't be equal to 0. Okay, and of course it's a little more straightforward when you have 8x. Just divide both sides by 8, and you get that x is cannot equal 0. Okay, so values for the variables that result in any denominator of 0 are non-permissible. So division by 0 is not defined in the real number system. Okay, so when we're dealing with rational expressions, you have to remember to take a look and see if you have any non-permissible values. Okay, so this concludes our introduction, and the next video will be example 1. So in our first example, we're being asked to multiply rational expressions, and to write our answer in simplest form, identify all non-permissible values. Okay, so the first step when you're working on multiplying of rational expressions is to factor if possible. Okay, so we want to factor anything in the numerator if we can, and anything in the denominator if we can. Okay, so we'll take a look at our first numerator here. We have a squared minus a minus 12. It's a trinomial. We can factor that into two binomials. So we can factor a squared into a, and then the factors of 12 that will give me 1 will be 4 and 3. We want negative 1, so the 4 is going to be negative and the 3 is going to be positive. And you can check if you're correct. Negative 4 times positive 3 is negative 12, and negative 4 plus 3 is negative 1, so we know we're right. The denominator that we have here is the difference of squares. So we can factor that into a minus 3 and a plus 3, and then we have times. And then we will factor this numerator, and it's a trinomial again, so into two binomials. A squared factors into a times a. 3 can only factor into 3 and 1. We want negative 4, so the 3 and the 1 both have to be negative. Check to see if you're right. Negative 3 times negative 1 is positive 3, and negative 3 plus negative 1 is negative 4. And then we have a binomial in this denominator here, but notice it's not a difference of squares because this a over here is not a square. So it looks like we just have a common factor of a that we can factor out, and that leaves us with a minus 4. Okay, so step 1 is done. We've completely factored. The second step is to reduce. Okay, so we want to reduce the factors that are common. So we have an a minus 3 in the numerator here and an a minus 3 in the denominator here. We have an a minus 3 in this denominator and an a minus 3 in this numerator, so we can reduce those. And then we have a minus 4 here and a minus 4 here. And it looks like there's no more reducing that we can do. So our final answer will be to take this binomial from the numerator and this monomial from the numerator and write them as a fraction. So you're going to have a minus 1 over a. And so you want to leave answer in factored form. Okay, and then the last thing that you want to do is to determine your restrictions, which we also know as non-permissible values. So if we go over here, where is the best place to look when identifying non-permissible values in products of rational expressions? You would look in the denominator. Okay, so that's what we're going to take a look at now. So we have two denominators. We have a squared minus 9. Okay. Now you can look for non-permissibles on with this one two ways. Okay, one by just solving for a. Okay, so you say a squared minus 9 cannot be 0, right? So bring the 9 over to the right. So a squared cannot equal positive 9. And so a cannot be equal to plus and minus 3. The other way to do it, of course, is to factor the a squared minus 9 into a plus 3 and a minus 3. And then setting each factor equal to 0, or in this case not equal to 0, and solve for a. Okay, and you get the same answer for both of them, right? A cannot be positive or negative 3. Okay, and our other denominator is a squared minus 4a. So this one we will have to factor, so we want to take the a out, which we've already done up here, so that's already, it's not like you're doing extra work. So, and set each factor not equal to 0, so a can't be 0, and a minus 4 can't be 0, so a cannot be equal to 4. And so you finish writing your answer by writing that a cannot be equal to negative 3, 0, 3, and 4. Okay, so down at the bottom here we have a your turn. So you might want to stop the video and try them out on your own, and then come back to them and just see how you did compared to what I'm going to put on the video. Okay, so for A, we have d over 2 pi r times 2 pi r h over d minus 2. And we can do some reducing before we do anything. And also note that you can't do any factoring here. Okay, so that would not be a first step on this one here. But if you take a look, you've got a 2 pi r in the denominator here, and you have 2 pi r in the numerator here, and they fit into each other once, right? And so what you're left with is a d here and an h over here, and in this denominator d minus 2. Now, don't think that you could reduce the d here with the d down here. We've got a monomial in the numerator here and a binomial in the denominator here. You cannot separate the d minus 2 in this denominator by canceling out your d's. Okay, you can't do that. Okay, so what that means then is that our answer is d times h, or d times 1 times h, which is dh over d minus 2. And your non-permissible values are that r cannot equal 0 and d cannot equal positive 2. Okay, so for b over on the right here, in the numerator, on the first numerator, we have a difference of squares, which we can factor as y plus 3 times y minus 3 over. And if you take a look at this denominator here, we could start by pulling out a common factor of r, and that would leave us with r squared minus 1, which you can see as a difference of squares. So in the next step we will factor that again. Okay, so let's take a look at what's over on the right here. We have r squared minus r, so we can factor out an r. That would leave us with r minus 1 over y plus 3, which cannot be factored. And so in our next step we are going to factor the r squared minus 1. So we leave y plus 3 and y minus 3 over r times r plus 1 times r minus 1, and then times that by r times r minus 1 over y plus 3. Okay, so what can we reduce? We can reduce a y plus 3 and a y plus 3. We can reduce an r minus 1 and an r minus 1. And we can reduce an r and a r. So what does that leave us with? A y minus 3 in the numerator and r plus 1 in the denominator. So we have y minus 3 over r plus 1. And our non-permissible values, well, I'm going to go up to our numerators here, denominators here and here, and I'll work out my non-permissibles. Okay, so on the left I have r times r squared minus 1. So I can see that r cannot be equal to 0. And I have r squared minus 1 over here. So I'm going to say that it can't be equal to 0, so r squared cannot equal 1, so r cannot equal plus or minus 1, and so I can put plus and minus 1 here. And then for the denominator that I've highlighted in blue, I can see that y cannot be equal to negative 3. Okay, so that concludes example 1. So the next thing we're going to take a look at in this section is dividing rational expressions. Dividing rational expressions follows similar procedures to those for dividing rational numbers. So we'll take a look at an example where we're just dealing specifically with numbers, and then we will add some variables and see what happens with that. So if you're dividing 5 over 3 divided by 1 over 6, recall from past lessons that you need to multiply the reciprocal of the second fraction, right? So we'll leave 5 over 3 as is, and then we change division to multiplication, and we get the reciprocal of 1 over 6, 6 over 1. Just like with multiplication, you're going to reduce if you can. So we have 3 into 3 once, 3 into 6 twice. Multiply our numerators together. 5 times 2 is 10. 1 times 1 is 1. 10 divided by 1 is 10. So over on the right then, we've thrown in some variables. So we have 3x squared over y squared divided by x over y. Remember, we're going to change division to multiplication and write the reciprocal of x over y, so y over x. And then we do some reducing if we can. So we've got x squared in the numerator, x to the 1 in the denominator. Remember, you're going to subtract your exponent, so 2 minus 1 is 1. So you're left with x to the 1 in the numerator and a 1 in the denominator. And we're going to do the same thing over here, okay? But what we're going to do is we're not going to take the exponent here of 1 and go 1 minus 2 to get negative 1. We're going to leave our y in the denominator. So we're just going to go 2 minus 1 is 1. So we have a y here. And we're going to leave, which we will leave in the denominator here. And then we'll just reduce this one to a 1. Okay, and so now what you have then is 3x times 1, which is 3x, and y times 1 in the denominator, which is y. Okay, and because we have variables in our denominators, we will have to concern ourselves with non-permissible values. Now, if you take a look on the right here, the question is, why is x equals 0 a non-permissible value? Because if you take a look at the original question, you only have y's in the denominator. But as soon as you multiply the reciprocal, you notice that the x is in the denominator. Okay? So we also have to include our x as a consideration for a non-permissible value, and so then we have to say that x can't be 0 and of course y can't be 0. Okay, so I'm going to end this little video here and we'll take a look at example 2 in the next one. So in example 2, we're asked to divide rational expression. We're going to determine the quotient in simplest form and then identify all non-permissible values. So the first step is to factor if possible. So we'll do that first. So in the numerator here, we have a difference of squares, right? X squared minus 4. So when we factor that, we get a sum and difference. So x plus 2 and x minus 2 over, and then take a look at this denominator. It's not a difference of squares because this x is not a square. It's not an x squared. So it looks like we just have a common factor of x, and so we are left with x times x minus 4, and then divide it by, and then we will factor the numerator here where we have x and x, and the factors of 6 that will give us 1 are 3 and 2, and it's provided 3 is positive and 2 is negative, and we can check that. Positive 3 times negative 2 is negative 6, and 3 minus 2 is 1. And then we will factor the denominator here, and we will get x and x. The factors of 20 that will give me 1 are 5 and 4. I want the 5 to be positive and the 4 to be negative. Okay, now we keep in mind that this is a division question. Okay, so our next step is to multiply the reciprocal. Okay, so x plus 2 times x minus 2 over x times x minus 4 times. Okay, so what was in the denominator before is now in the numerator. And what was in the numerator before is now in the denominator. Okay, and if you have guessed that our next step is to reduce, you are correct. And so let's see what we can reduce. We have an x minus 4 and x minus 4. We have an x minus 2 and an x minus 2. And it looks like we have nothing else that we can reduce. Okay, so in the numerator we are left with x plus 2 and x minus 5, and in the denominator x and x minus 3. Okay, so we want to leave answer in factored form. Okay, so our answer is x plus 2 times x plus 5 over x times x plus 3. Now, don't multiply this out, okay? That's what I mean by leave it in factored form. Just leave it as x plus 2 times x plus 5 over x times x plus 3. Okay, so next are the non-permissible values. So what we want to do, we want to take a look at our original denominator. So we have x squared minus 4x, and we will factor that, and we've already done that, so up here, so you can just do that again here. And we can see that x cannot be 0 and x cannot be 4. And then our other denominator here is x squared plus x minus 20, which we already factored earlier to, oh yeah, and then just put that can't be 0, right? Okay, which we already factored to x plus 5 and x minus 4. So we can see that x cannot be negative 5 and x cannot be 4. Okay, now we also have to include the denominator right here, okay, which used to be the numerator here, but because we had to multiply the reciprocal, the numerator here now becomes the denominator here. So we have to do that one too. So we have to figure out what our non-permissible values are for x squared plus x minus 6. Okay, and then we will factor again. This should be plus and minus. So x can't be negative 3 and x can't be 2. Okay, so let's write our non-permissible values. I'm going to go on in ascending order, sorry. So x can't be negative 5, negative 3, 0, 2, and 4. Okay, so that is number 2. I have a your turn right here, so if you want to just stop the video and try it on your own and then come back to it after you finished. Okay, so let's take a look at the your turn. We're going to start by factoring, so we will take the numerator and factor it into c minus 7 and c plus 1 over, and we have a difference of squares here, so we're going to get a sum and difference of c plus 7 and c minus 7. And then I have a division question here, so I'm going to write it as multiplication right away, and I'm going to take what was the denominator, it's now going to become my numerator, and I'm going to factor that. I can only take a c out of this expression, c squared plus 7c, and when I factor it I get c times c plus 7. And then I will take this numerator, which now will become my denominator, and I'm going to factor that into c plus 7 and c plus 1. Okay, so we're going to reduce. So we can reduce our c minus 7s. We can reduce our c plus 7s. We can reduce our c plus 1s. And we are left with a c in the numerator and a c plus 7 in the denominator. And so we get c over c plus 7. And our non-permissible values are that c cannot be. So if I take a look at this factor here, it can't be equal to negative 7. And if I take a look at this factor here, c cannot be positive 7. And then remember, I've got to go with the denominator and the numerator here because I had to multiply the reciprocals. So if I take a look at this numerator here, c cannot be 0. And we've already done c plus 7 over here. Okay, so I don't have to do that again. And the same thing for this one here. I've already done c plus 7, so I don't have to do that one again. And so I have c plus 1, and that means that c cannot be negative 1. And so that concludes our example number 2. Okay, so in example 3, we're going to multiply and divide rational expressions. We're going to put multiplication and division in the same question, and so you've been asked to simplify and then state what the non-permissible values are. So we are going to start with factoring, and we're going to take this numerator here and we will factor. Okay, and I'm going to do that over here. We'll use inspection, because that's what I would do myself. Okay. Alright, so I know that there's only one way to factor 2m squared. That would be to get 2m and m. But I have two ways that I can factor the 15. The 15 can be 15 and 1 or 5 and 3. So I'm going to go with the 5 and 3 to start with, okay, and I will place them into my brackets, and I'll just start with the 5 here and the 3 here. Now I want to get negative 7, okay, so I'm going to test, and I'm going to go 2m times 3, which is 6m, and then 5 times m, which is 5m. And can 6m and 5m give me a 7m? No. So what I'm going to do next is I'm going to switch my numbers around. Okay. And I'm going to put the 3 here. Oops, I think I already did that, right? I'm going to put the 3 here and the 5 here, and I'm going to test again. So 2m times 5 is 10m, and 3 times m is 3m, and can I get a 7m from that? And the answer is yes, as long as my 10 is negative and my 3 is positive, right? Because negative 10 plus positive 3 is negative 7. So in order to get the negative 10, I have to make the 5 negative, okay? Because 2m times negative 5 will give me negative 10m. And then to get the positive 3m, I make the 3 positive because positive 3 times n will give me positive 3m. One other thing to check is to make sure that positive 3 times negative 5 is negative 15, and it is. Okay, so that gives me 2m plus 3 times m minus 5 over. And in the denominator here, it looks like I have a common factor of 2m, so I will factor that out. And I get 2m times m minus 5. Now, I have a division here, which I know I'm going to have to multiply the reciprocal of, so I'm going to do that right now. So I'm going to go 6 over, and then I'm going to factor this. And this is a difference of squares, okay? So I get a sum and difference when I factor that. So I get 2m and 2m, and then plus 3 and minus 3, and then times 3 minus 2m. Okay, so now we're going to reduce what we can. we have a 2m plus 3 and a 2m plus 3. We have a m minus 5 and a m minus 5. I have a 2 which can go into itself once and will go into 6 3 times. And then I take a look at what I have here and here. And I notice that I have the exact same terms, but my signs are opposite, right? So my 2m in the denominator is positive, but in the numerator it is negative. And my 3 in the denominator is negative, but in the numerator it's positive. Okay, so what you want to do is you want to factor out a negative 1 from the one in the numerator. Okay, so I'm going to take the negative 1 out of here. Okay, and I'll do that over on the side here. So I'm going to factor out a negative 1. Okay, and so I'm going to go 3 divided by negative 1 is negative 3. Negative 2m divided by negative 1 is positive 2m. Okay, and so I will just rewrite this as a negative and a positive and a bracket. So negative 1 times negative 3 plus 2m. Okay, now if you go over here, how do you know that 3 minus 2m and negative 1 times 2m minus 3 are equivalent? Well, you know that because if you take the negative 1 times the 2m minus 3 and you expand, okay, so you're going to multiply the negative 1 through, you will get negative 2m plus 3. And if I rearrange my terms, that would be 3 minus 2m. And so negative 1 times 2m minus 3 is the same thing as 3 minus 2m. So that's, I mean, the whole point of this question is to show you that we haven't actually changed the value of anything up here. Okay, but notice they are now the same, so I can reduce. Okay, so what do I have for an answer? Okay, well, in the numerator I have all these 1s and 3s and negative 1s that I can multiply together. So I'm going to go 1 times 3 is 3, times negative 1 is negative 3, times 1 is negative 3, over 1 times m, which is m, times 1 times 1 times 1, which is just m. Okay, and now I want to list my non-permissible values. Okay, so I have this denominator that I need to consider, and because I had to multiply the reciprocal on the middle term, I have to consider this numerator, and that's it, right? If I'm going to work out my non-permissible values, so for 2m squared minus 10m, that's 2m times m minus 5, and so I can see that for the 2m, m is not equal to 0. Okay, and the m is also not equal to 5, right? And then for the 4m squared minus 9, I already factored it into 2m plus 3 times 2m minus 3. And so when I take the first factor and make it not equal to 0, I need to solve for 2m to start with, and then for m, so I'm going to divide by 2 here, right? So m cannot be equal to negative 3 over 2. And then on this one here, I'll do the same thing. So 2m minus 3 can't be equal to 0, so 2m cannot equal 3 divided by 2, so m cannot equal 3 over 2. Okay, so my non-permissible values are that m cannot be equal to 0, 5, and plus or minus 3 over 2. And so here is your final answer for this. Okay, and then once again I have a your turn here, so if you want to just stop the video and try it on your own, and then when you're done, run the video and see how you did. All Alright, so let's see how you did. In the numerator here you can factor out a 3, and that leaves you with 3 times x plus 4. In the denominator you should have gotten 3x plus 4 times x minus 3. And then this is division, so you should have went multiplied by, and then take what was in the denominator and put that in the numerator, and what was in the numerator, put that in the denominator, and we will factor neither one of them. Okay? And then times, and we leave the 2x minus 6 in the numerator, but we'll factor out the 2. And then of course x plus 4 cannot be factored. Okay, so let's reduce what we can. The 3x plus 4 and the 3x plus 4 can reduce. The x plus 4 and the x plus 4 can reduce. The x minus 3 and the x minus 3 can reduce. 3 can go into 3 once and into 12 4 times, and then 2 can go into 2 once and into 4 2 times. So when we write our answer, then we're going to have 1 times 1 times 1 times 1 times 1, so that's 1 over. And then in the denominator we're going to have 1 times 1 times 2 times 1, which is 2. And then we can list our non-permissible values, so x cannot be equal to. For the 3x plus 4, you should have gotten 3x cannot equal negative 4, so x cannot equal negative 4 over 3. So one of your non-permissibles should be negative 4 over 3. For this denominator here, this x minus 3, this factor, you should have 3. And then remember, we have to include this denominator, right? So 3x plus 4, which we've already done over here, so we don't have to repeat that. And then this x plus 4, which will give us a non-permissible value of negative 4, and that concludes this question. And that also concludes 6.2.